Hello, welcome to this video. Today I want to explain about the RLC resonance circuit analysis. Okay, this is the series resonance circuit that we want to analyze, and we use Kirchhoff voltage law to obtain the current transfer function, which is IS. Okay, from the circuit given, we may use a counterclockwise loop to obtain the equation like this, which is negative Vs plus Is R plus J omega L plus 1 over J omega C equals to 0. So from this equation, we may arrange it to get the current transfer function, and which is Is equals to Vs over R plus J omega L plus 1 over J omega C. So from this Is equation, therefore we may get this Is equals to Vs over Z. So for the final derivation, Is equals to Vm over square root of R squared plus omega L minus 1 over omega C squared. Okay, next let's take a look how we plot the frequency response, which is Is versus frequency, which is omega, using MATLAB. So let's have a look. Let's take a look here how you get this. Okay, this is MATLAB, and this is the script that we've made to gain this kind of graph, which is for the y-axis here we have transfer function, which is hash f, and for the x-axis here we have frequency, which is omega.
Okay, now we will show you our first calculation, where value of R we set it to 2 ohm, inductor 10 Henry, and for the capacitor 10 farad. Okay, to get the value of resonance frequency, we use this formula, which is omega naught equal to 1 over square root of LC, which then we will get 0.1 radian per second. For the lower half frequency, we use this formula, which is omega 1 equal to negative R over 2L plus square root R over 2L square plus 1 over LC. Then we will get the answer 0.04 radian per second. For the upper half frequency, we got the value, which is 0.24 radian per second. As for the bandwidth, the formula for bandwidth is B is equal to omega 2 minus omega 1. The omega 2 and omega 1 we can obtain from the previous calculation, which is here, this one and this one, which then we will get the answer 0.2 radian per second. For the quality factor, the formula for quality factor is Q1 is Q equal to omega naught over bandwidth, which we will get 0.5. So now let's take a look at our simulation 1. This is the coding that we have conduct using the MATLAB. As you can see, here we are already set the value of Vm to 20, the value of capacitor to 10, the value of resistor 2 ohm, and the value of inductor 10 Henry. Okay, after we run the coding, this is the result that we obtained from the MATLAB, which as you can see here, this is the graph for our first simulation, and the left one, this is our is the result that we have obtained by using the MATLAB. As you can see here, this is the resonant frequency, which is 0.1 from the MATLAB, and our quality factor we got 0.5, and for the bandwidth we got 0.2. Okay, let's compare the result from the simulation to our manual calculation. Okay, this is our resonant frequency 0.1, for our bandwidth 0.2, and for our quality factor is 0.5. As you can see, we got the same value from the simulation from the MATLAB. Now we will move to our second calculation, which we only change the value of R from 2 ohm to 4 ohm, and the value of LC maintained 10 Henry and 10 farad respectively. Okay. For our second calculation, the resonant frequency that we obtain is 0.1 radian per second, and for the lower half power frequency, we got 0.2 radian per second, and for the upper half power frequency, we got 0.42. For the bandwidth, we got 0.4 radian per second, and our second quality factor, we got 0.25. So this is the simulation, this is the coding that we have used. It's just the same coding as the previous one, we just changed the value of 4 here, as you can see. From 2 we change it to 4, and others are the same coding. Okay, after we run the coding to the MATLAB, from the MATLAB we obtain this result. As you can see, this is the graph that we obtained for our second calculation, which only half. We got half from the previous one. The shape of the graph is half than the previous one. As you also can see here, this is the result that we obtained from the MATLAB, which the resonant frequency they get is 0.1. The quality factor is 0.25 and the bandwidth is 0.4. Let's compare the result to our manual calculation, which our resonant frequency is 0.1 radian per second, and our bandwidth 0.4 radian per second, and our quality factor, the second quality factor we obtained 0.25, which is the same value as we got from MATLAB. This one, and this one. So next we will move to our third calculation. For the third calculation, we decide to change all three values of resistor, inductor and capacitor, which is we change it to 6 ohm for resistor, 11 Henry for inductor and 9 farad for capacitor. For the resonant frequency, for this calculation we got 0.1 radian per second. For the low half power frequency, we got 0.0178 radian per second. And for the upper half power frequency, we got 0.5632 radian per second. And for the bandwidth, we got 0.5454 radian per second. And the quality factor that we obtained from our calculator is 0.1834. So now, this is our simulation 3, which is our coding. As you can see here, we only use the same coding as the previous one. There's nothing changed, only at the value of R, C and L. As you can see here, the value of R we change it to 6, the value of L we change it to 11, and the value of C we change it to 9. So now let's take a look at the result. After we run the coding, this is the result that we got from the coding. As you can see, this is the graph, the third graph that we obtained. And the left one is the calculation that provided from the MATLAB, which the resonant frequency is 0.1005, and the quality factor they got, the third quality factor they got is 0.1843, and the bandwidth they got is 0.5454. Okay, now let's compare the result from our manual calculation. which for the resonant frequency we got 0.1, the bandwidth we got 0.5454 radian per second, and for the quality factor we got 0.1834. It's the same as the result from the MATLAB.
For the comparison of quality factor Q with calculation and simulation of MATLAB. This is our quality factor, which is we have initial quality factor Q1, second quality factor Q2, and third quality factor Q3. We have comparison about calculation value and simulation value. Based on the formula of quality factor, the quantity factor is inversely proportional to the bandwidth. So, the lower the value of bandwidth, the higher the value of quality factor. That means the greater the selectivity. Therefore, the best selectivity is Q1. That means initial quality factor Q1. The function of series resonance circuit occurs a particular frequency, so it is used for filtering and tuning purpose, as it does not allow unwanted oscillation that would otherwise cause signal distortion, noise, and damage to circuit to pass through it. For the application series resonance circuit, series resonance circuits are one of the most important circuits used in electrical and electronic circuits. They can be found in various forms, such as in AC mains filter, noise filter, and also in radio and television tuning circuit, producing a selectivity tuning circuit for the receiving of the different frequency channel. For the conclusion, we can say that the waveform of each resonance are different due to change of value of R, L, and C. And for the best selectivity of quality factor is Q1, which has the higher amplitude. Thanks for watching this video. Bye bye.